Okay, hello everyone. I'm back. As I told you in this my previous video where I explained the plan of this channel. So initially I need to shoot some videos with the content, and it will be not very organized, very diagrams and animations and all that. But yeah, it will be a good content as seen as a part of a discussion, or you can say as a podcast or a one-way podcast for simplicity. So here we are again discussing the topic here is the backend for threads. Okay. So I recently rewatched a good video on threads patterns on backend systems. You can find it on internet using the search of the patterns behind backend systems by Hussein Nasir. I will link that in the description. And I have few thoughts about it and few re-explanation about the things that he tried to explain. And I have most of the thing I will reiterate because those things are very well explained there. So you can watch that first and you can come to here, or you can post the comment or whatever you got in there in that video, and you can post it down the comment so that I can see them and try to explain if I got any answer or any good explanation about it. So the thing is the exploration of the threads when it's come to making the backend systems. Okay. And the thing is that we need to take a decision while making an application from scratch whether to choose a multi-threaded model or a single-threaded model. For the simplicity, there are two. There are many sub types of these also, but for simplicity, and these are not simple decisions to take. We need to have a lot of pros and cons and the trade-offs and all those things. So for starting, like, what is a thread here? So by thread, for the simplicity, we go for just as an alternative of a process. So for a process to work, to make some task to be executed by the CPU, a process needs to have at least one thread. Okay? And then that thread CPU will reschedule and manage. So if our application or if our server have multiple processes or multiple applications running. See, so all those processes will have at least one thread, and all those threads will be registered by the kernel or the CPU, and that CPU will do the scheduling. Okay, so if it is a single threaded or a single core processor, so it will do the job sequentially. Okay, and if we have a many applications running in a single server and all those things needs to do something, so a CPU can can do the one thing at a time. So those processes will load those, will spin up those threads and go to the sends to the CPU, and then CPU store them in a queue or some kind of specialized scheduler, and based on priority or based on many strategies, first come first serve or all these things, CPU one by one try to execute it, and then we got our thing to be got processed. Now in that video, it is the simplest thing, like if we have a one core or a one CPU and we have a one process and we need to do something, it will simple, the request came and go to the process and then go to the CPU and do all the processing and get back to us. And life is simple. Now the things complicates where when these multi-core CPUs are coming to picture, where they claim or they do parallel processing. What parallel processing is do that that CPU is capable to do not schedule multiple threads one by one. So earlier on one core essentially uh, since it's a one core, only one thread is processing at a time. But if it is if I have multiple cores, that cores is a processing or main, the meat processing thing of the whole CPU part, and that CPU in the multi-core system will distribute those threads among these four cores. So at a time, maximum or the typically four minimum It could be minimum four, depending upon how much the traffic, how much the things are waiting to get processed. But yeah, at max, four things can be processed parallelly, and that will make huge performance boost since all of the things happen internally in a one servers. So if we have four servers single core and one CPU with multiple cores, so there is a sweet spot which is now we can say that 16 cores, 30 cores, 62 cores, 64 cores, they works in the to the power. But you have not seen now like a million core or thousands core, not a near future or not recently. It's because there is a high cost of making that technology feasible to make put all those things in a single CPU chip. And also we need to have a sweet spot because uh, we need to have those things to be distributed among servers, and but those each server needs to be powerful enough to you know call itself a node, a utilized or a processing node. So right now, typically we see the 32 and 64 cores. But coming back to our question, like how our backend sees it. And the thing is that the request when it comes to a server, and let's take an example. If we have an application which is listening on port 443, and that listening needs to be done via a process or a thread, and that thread needs to be scheduled in the CPU. For a single CPU core, it is just any other task like, yeah, a request came, it will do the job. There are a lot of things will it will do in between, like TCP connection, handshake, and all that. But essentially, that when it's come to the multi-core, we want to utilize those things because we have now got our capacity four times if it has a four cores. So to be we are hungry. We need those four cores to facilitates us to get more number of requests, essentially the throughput, which is us this new system needs to be able to process multiple or more requests per second. That is the throughput. So what do we do? uh, we can do multiple things here. Okay, so the first thing, it is a naive thing that it can remain single threaded, and these are the two opposite ends of the whole discussion in that video, which is that first, initially due to the lack of multiple cores, we need to go for it single thread and single process or single core. But at the far, at the latest technologies, we also see the Redis, Node.js. These are not multiple threaded by default, but single threaded, even on the multi-core CPU. So that concept and that architecture needs to be understood, that to get an idea why they have gone that way and why they are not utilizing these multiple cores. So that's a separate video for another day. And also the multi-core, if we go for each thread for one, essentially utilizing those four cores doing processing parallelly, we are essentially achieving true concurrency. Okay, so in the sense, like at a time, at least your at most four requests can be processed parallelly. That it's concurrency in its root term, but nowadays the concurrency doesn't mean it. They do not need to be run parallelly. It means that our system should be able to handle without a fail a request, or sorry, a large number of requests, and those requests can be have some delay in between. They do not need to be run in parallel because they use the waste time to solve this problem. What it does, let me explain it. So what they do, that for to increase the throughput, all the things are very easy to explain for the single core, but it can be applied to the multi-core. So for the single core, to achieve the concurrency, and sometimes it speeds the multiple core concurrency because uh, depending upon the type of request it is. So if a request needs to wait somewhere in between to get completed, you know, and that waiting time, it's not up to the server to be done, or if it is, then it is a lot of taking a lot of time. So if we solve that problem, so we can, complete the thread, or we can utilize those that time, that waiting time, to entertain another request. So essentially, if we are blocking everything for a fun one request to fulfill first and then move to the second request, and if that one request have something to do, I am not going into the detail, but have something to do first, and for that, what that thread need to be wait, and while it's waiting, it cannot accept more request. So to essentially the throughput is for that time, for that second, it's one. To solve that thing, we need to utilize that remaining time, and that what most recent event loop, you have heard this term event loop, are doing. What they does, they do not wait for that waiting time period. They essentially put that request or put that thread into queue, or in some sort of waiting list, and start entertaining other requests. And same, if there are 1,000 requests waiting for something, that will not hold our servers to accept more requests. So our system can process or can accept more requests concurrently, and that is what concurrency means in these new terms. Okay, I have a few more things to discuss regarding the same topic, like previous, like this video, but I will post it in a different part in the same continuation of this part, so that the rest of the thing I will discuss in part 2. Okay, and you can guys comment on this video if you want any question, any suggestion you want to give, then I'm all in.